Dear Heavenly Father, I pray that you would bless this class and bless this week, help us to stay focused, and also keep the end in sight. Lord, we pray that you would just bless these students. In Jesus' name, amen. Okay, problem set 75 is probably like half of the calculus exam and half of the important things in calculus, and that is the continuity of functions. Okay, there is like, what? That's not even the continuity of function. Okay. What do they title lessons that they're not even on? That's dumb. Good thing you're using pencil. All right, so we have intermediate value theorem. This is still important, but less. Okay. Imagine you're going on a hike, right? And you start here, right? They have like the little log book where you sign in, and then you write your name. Like if I die, this is what time I came through here, right? And then you go on your hike, and then you go up the big mountain. Then you get to the snowy part, and you camp out, right? Okay. So, in the morning, day 1, you're here, right? Day 3, you camp out up here. So necessarily, you must have gone through this spot, right? Because if you're here on day 1, there's only one path up the mountain, and here's where you are on day 3. Then, at some point, you must be here. When is that? Trick question. You don't know. Right? You don't know if you ran this whole part and it's still day 1, and then your day 2 campsite is somewhere up here. Or if this part was really hard and then there was a little like ski lift that just brought you to the top, right? You don't know. But you know that necessarily if you started on this path and you went from here to here, you must have gone through that intermediate value. Why? Because it's between point A and point B. Are we surprised? No. Likewise, if you have a function that goes between a point A and point B, then you must necessarily hit. Let me just draw a picture. So if you start at point A and your function meets the requirements for the intermediate value theorem, then I could choose some y value between f of A and f of B. Let's say this point right here. And your function must have gone through that point at least once. Okay? Might be twice, might be 100 times, right? If it's like, but the intermediate value theorem says that if you meet its conditions, then on this closed interval from A to B, if you give me a point f of C, which is between f of A and f of B, then there exists at least one x value, C, between A and B. For that gives you that y value now. Okay, this is exactly the same as this picture right here. Okay, here's your point A. Like even if I made this graph, right? Here's point A. Here's point B. So if I put this on a graph, my x value would be A, my y value would be B, and I said, hey, is there any point, here are my y values, right? F of A and F of B. I said, is there a point at which you are right here. Of course there is. Because this y value is between f of a and f of b. So there must exist an x value here. Is it a no-brainer? Yeah, kind of. Is it always true? No. Here's why. Because your function could have a hole right there. Right? Or your function could jump. Right? Or your function could have an asymptote. So we have to look at the specific conditions required for the intermediate value theorem to work. Here it is. Are you ready? Are you ready? Okay. So here are our conditions. These are the things you must prove to be true before ever using this, even though it seems so ridiculously obvious that we're like, of course, if you start here and end up there, you must have gone through there, right? Unless there's a little ski lift right here that takes you straight to the top. So, what I'm saying is that, number one, your function must be continuous on your closed interval a, b. What does that mean? It means that no jumps are allowed, no asymptotes are allowed, no holes are allowed. It must be continuous. That means you must be able to draw it with your pen without lifting it, okay? So, that's not continuous. This is. The second condition is that C is between lowercase. So some value C, they're using C to mean this value here. Okay? So the y value that you're looking for has to be between the starting y value and the ending y value. Is that a problem? No, because that's what we're trying to figure out. So if those two things are true, then the intermediate value guarantees that there exists, my handwriting is, and spelling is like totally off. So there exists an x value, we'll call it what's a good letter other than x? T. T was first. So there exists a value t that is between a and b. Such that f of t equals c. So this is like the math lingo for it, but really all you're saying is if you start at point A and you go to point B and you want to find some point C that has a y value in between, your function must at some point cross that line. That's it. And you can find that value. Okay. So that is the intermediate value theorem. Now, I used something in the intermediate value theorem that is quite important to us. And that is continuity. Which is probably why they claimed that this lesson was about continuity. So what makes a function continuous? Since you have to prove continuity to use the intermediate value theorem, you're going to have to prove continuity on any function that you use this on, okay? So, the lazy definition is that you do not lift your pen whilst drawing. So if you can draw the function without lifting your pen, it's continuous, okay? But the legit definition is as follows. The limit for every point as x approaches your value, your point C of the function, has to equal, from the left, has to equal the limit as x approaches C from the right of your function, which has to equal the value of your function. So basically, as you go from the left to your point and from the right, those have to match up, and then the actual value has to be there. That tells you if it's continuous. So this is continuity at a point, and then overall, if you want a function to be continuous, this has to be true at every point. Sound good? Okay. So I'm going to have you start Z homework.